Hello everybody, this is Carol speaking. Welcome to our PolyWorks webinar. And today we are talking about how to quickly inspect bent tubes and rods. And let's welcome Todd Anderson as he is our presenter today. Todd is a member of the technical support group. And let me remind you that if you have any questions during the webinar, please use the questions panel. I will be monitoring the questions throughout the webinar, and we will have a short Q&A session at the end. If we don't have time to answer all the questions, we will get back to you by email. And yes, we are recording this webinar, so it will be available for later viewing. So Todd, it's all yours.
Thank you, Carol. Back in 2013, we released IMTube as a way to measure bent tubes and rods. As you know, the inspector module has grown so much over the years. Well, so has IMTube. In today's webinar, I want to show you how quick and easy it is to use to inspect tubes and rods. When we're dealing with the inspection of tubes and rods, they're typically the measurements that are being used inside come from a drawing or a set of tables. On a drawing, we may have XYZ coordinates for the straight sections of the tube or the rod and a radius that's assigned based off of a mandrel. In other instances, when we have an automated machine that is doing the tube bending for us, this information is conveyed via a table telling us what the length, the radius, and the angle are. This is referred to as an LRA table. So what IMTube is, it's a set of macros that have been created that can easily go through and do these measurements for us. If you're unfamiliar with using the LRA table, one of the things I wanted to show today was this is an example of, say, an automated machine where the length and rotation are controlled by the machine itself. So as it extrudes the pipe out to a mandrel about which it's going to be bent, the rotation is described as how the tube may rotate towards that mandrel, and then the length that it extrudes out. So that would be the L and the R of an LRA table. In addition, when the tube is bent around the mandrel, we would have an angle at which it's being bent to. This would be the A. So if you never have seen that or unfamiliar with the term LRA, I wanted to kind of do a quick, brief introduction to that so you'll understand what I'm explaining if I refer to it as an LRA table. Now, when we have PolyWorks up and running, the IMTube macro comes from our Technical Support Zone website. When we download it, it's going to be downloaded in the form of what we call a visual layout file. To load it into the software, all we would have to do is go to our Tools menu, Visual Layout, and Load. This will prompt us to go to the file where it's located, and you can see that this is what I have downloaded from the website, which is the latest version of the IMTube. We simply open it, and you'll see that your icons change across the top of the screen. This is set up now to go through and measure tubes. The main standard toolbar that was there can still be available. It's just hidden right now. If you wanted to bring it back in, you could simply go to Main Objects and you can pull that back up if need be. However, if we're only measuring tubes with this layout, what we've done is made it quick and easy for you to use. The workflow when we're dealing with this is, I'm going to kind of separate this out just a little bit from the other icons. You'll see that these icons are showing across the screen. This is our workflow. At the very beginning, when we start and launch the macro itself, we have the options page. So what we'll show with this is one of the major improvements over the years we've seen is we have the ability now to create nominals. Not only do we have the ability to create nominals from a CAD model, if we want to, we can actually go through and create the nominals of the straight sections of tube using an XYZ file or an LRA file. This gives us the ability to create those nominal features that when it comes time to measure, they're paired up with the measured and the nominal are paired up to each other, and the calculations are done very quick and easy. This also gives us the ability to do multi-piece inspection where that's one of the tools that has grown into the software over the years. Now, setting everything up, we have a first section, which is the create nominals. We can go through and establish our start and end planes based off of letting the software automatically derive what those are from the nominals that were created from the previous section, or we can pick on CAD if we need to go through and have separate surfaces that represent the ends. The bends themselves are set to automatic, where in this case for a CAD model, this will go through and it will calculate what the bend radius should be. If we have the other examples, say X, Y, and Z, I have the ability to use internal or centerline. If you're unfamiliar with the terms for internal and centerline, internal will be the smallest radius of the tube. Basically, this is the section of tube that would bend around the mandrel. We can measure that particular radius, or we can go with the center line. That would be going down the center of the tube. That's that one that we physically can't touch. However, we can calculate that from the data that's been provided. So we give you many options when we're going through and creating nominals. When it comes time to measure, we also give you the ability to go through and do this measurement using two different methods. We can probe and or scan, or we could do a combination of both. In this case, I would like to probe the cylinders, but maybe for some reason I want to scan the end planes. So we can use either a combination of probing and scanning, or just individual probing or scanning. Well, in this first example, I'd like to show you, I'm going to set everything inside of here to be scan. So what I would like to do is do an inspection of a part from a CAD model and use the measuring of scans to go through and create our measurement. So with those pre-selected, I'll click OK. And as soon as I do that, you'll notice that the toolbar has changed as far as the commands go. This is now set up for a CAD model to come in. So our workflow is left to right across the screen. The first thing is we should import a CAD model. So for this example, I'm going to use a bent rod. So with this particular rod, you can see that we have 4 straight sections and 3 bends. Our workflow again is left to right across the screen. So the next step is to create the cylinders. You have a choice when you're going through and creating the cylinders. You can either start left to right or right to left, but you should always go in the direction you start with. Do not go through and say piecemeal this one, and this one in that order. For this, I'm just going to go ahead and start this side and go from right to left and simply select all of my cylinders. When I'm done, I right click and the nominals have been created for the straight sections. After this has been created, we can go to our next step, which is to create the inspection project. So when we launch this, PolyWorks runs the set of macros that goes through and creates all of our construction geometry that we need to use when we're going to go through and do our measurements. Since we're set to, we wanted this to be scan, I can simply come through and click the play inspection button here. Now, what this will do is, depending on what you have preset as your scanner, and for me, in this case, I'm going to use a PolyWorks line scan player. I don't have a hardware device in front of me, but I've scanned this particular rod in the past. Since this is pre-selected, when I hit play, the play inspect will start, and it knows exactly what is being used. Had I had a scanner up and running beside me, then it would turn the scanner on and we would get the ability to go through and scan. In this case, I have a scan that has already been done, so I'm just going to let the player go ahead and run. When we're doing this, you'll notice that at the bottom of the screen, we are using real-time quality meshing. I have them turned off because it will create many colors, especially when this is a cylindrical object through here. However, because we still have that real-time quality meshing, we can use those and turn them off or on and off when we're using this process. So I'm going to go ahead and continue and let it finalize the mesh. This will take about a second or two. However, once this is done, there's more that's going on in the background. What will happen is the macro will continue. It will run a best fit of the scan data to the nominal features that we have inside of here that have been created, and or to the CAD model, sorry, that was there. The nominals will extract the measured values, and our measurements are complete and done. It takes me longer to explain what happens than what actually has happened. This has actually gone through and has done all of the measurements for us, and it has reported everything out down in the report tables as the report section as tables. You can see that we have an intersection table. So if I launch this, in this case, if we were doing an XYZ measurement, then you would see the results for X, Y, and Z. If you're wanting an LRA table, we actually go through and we complete that one as well. And you can see that we have an LRA table. We also give you a tangency table. So if these are numbers that are needed inside, along like with the intersections as this goes through, we have the ability to report that as well. So the improvements of IMTube over the years has been to the point where we can now have CAD models inside, we can create nominals, and the work is done for us very quickly and easily with the Play Inspect. Now with this also gives us the ability to use a new piece where we can simply come through and say new piece, my project needs to be saved, and a new piece will pop up. And when new piece pops up, you'll see that the Play Inspect starts immediately for us. So when we hit create, it automatically remembers what we had done before because the sequence had been generated, and we can go through and measure the whole part. I'm going to cancel this right now because you guys have seen me do this one time. Now, this is one example of us going through where we can do a measurement where we have nominals that have been created from an LRA table and or if we have a CAD model. What I'd like to do is show a second example where we would go through and do a measurement that, in this case, we're bending pipe or tube or rods out in the field. Or maybe we're trying to correct something that has changed in a buildup on the shop floor. So one of the things we would like to do is scan the tube that may have been adjusted or created in the field and measure it, as well as document it to send it back to CAD. In this case, we would go through and use the options of when we pop this up that we're going to not create nominals. However, we're going to go through and do our measurement using, say, scanning the cylinders and scanning the end plates or the end planes. But we also have the ability to come through and have it either when we're measuring the bends to have them done automatically from the internal, which is the smallest radius on the tube, or through the center line. So for this example, what we're going to do is I'm going to actually bring in that same scan that I did of the rod. And what I'd like to do with this is have it go through and figure this out for me. So by launching this, you'll see that our toolbar has changed again, and it's much less as far as the commands go. So in this case, we can go ahead and launch to create empty tubes, the empty features inside. This brings the tube configuration. How many sections do you have? 4. What was the center line bend radius? Well, for my mandrel, it's 38.1. Since most of my bends, we have them all to be the same, you'll notice that everything fills in for us quickly. If I need to, I can go back and change individuals. However, as soon as this is created, we're going to give you a warning. The manual selections and fit are needed in order for this to be measured. So with this involved, you can see that we have our features in the tree. Now it's time for us to scan the part. Now I can hit play and that would launch my scanner, but I want to show you the ability for us to just go ahead and launch the scanner itself and us to go through and just to do a scan. So I'm going to bring back in that initial scan that I had done before. So the part is scanned itself, and I'll wait for this to process, finalize my mesh. And now I have an object that's scanned on the screen. The previous versions of IMTube, we ask you to go through and scan each individual section of the tube as you were going through, kind of you were piecemealing it. So you would start with the ends and then select the tube and then scan the all of the cylinders. You would come back through and scan the bends. And this particular version of IMTube, what we would like for you to do is scan everything from the very beginning. So you have everything on the screen there in front of you. For us to go through and do the measurements, it's as simple as just selecting those particular items, and you'll see these are the ones that are actually shown on the screen. These are the items that I need to fit to this scan data. So I can come through and say define measured, make sure that I'm set for fit, and go through and start on one end and go through each individual object. So in this case, I'm going to start with a plane, select, create, and just simply work my way through. So it wants cylinder 1 here. I'm going to grab everything and just work my way down, following what it's asking for in the tree as far as the scans go. So cylinder 2. I got a little too much right there. And we'll try cylinder 3, 4. And my end plane. Now in this, I went through when I had scanned, I had gone a little bit, my hand was a little shaky, and I actually had scanned, had selected a little bit too much for my cylinder number 3. I have the ability to go back to cylinder number 3 in the tree and simply come back through, make sure that's it, yes. I can come back and define the measured again. You'll see that you have a warning that there is one that already exists there. However, when I come back through and I grab my selection this time, I'm going to be a little more careful with this and try to make sure that I just stay in the straight section itself. And I will hit create. Now, everything will update inside of the model. One of the things that you may see here is this starts to look like something that's not exactly quite right. It's actually showing the bends on the opposite side or outside of the model. This is going through when we had created the cylinders themselves. When I was using the directions, as I was grabbing the data itself, the directions of the cylinder may not be correct as far as what the calculations are going. So we expect this to happen, and we can correct that by simply just clicking the button correct cylinder orientation. When we do this, now you can see that the bends are exactly where they should be on my model, and the radius has been calculated inside. Again, under the table items down here, the intersection table has been created, as well as the LRA table. So with these two examples, I've been able to go through and show how easy and how quick it is for us to go through and measure tubes and rods that are bent from using either a CAD model, LRA data, and or if we don't have any nominals at all, just to inspect a tube by itself. I hope that everyone will download the latest version of IMTube and give it a try. With that, I want to turn it over to Carol to see if we have any questions.
Actually, we do have some questions that are coming in quite a bit. The first one, it deals with the options page that you showed almost at the beginning. So at the bottom of that interface, can you explain the coped ends? So what does that deal with?
Okay, so there was a parameter, if I understand this correct, someone had seen the coped ends. Basically, there's an advanced section. What I didn't go over was some of these advanced tools. Inside of here, coped ends. This would be if your pipe, the end of your pipe, your tube, or the rod has been cut so that it will match an existing mating surface that may be another tube. So what will happen is a radius is cut normal to the end of the tube, where that tube itself has like a saddle shape to it. It's not perfectly flat. Well, when we're going through and we're creating the end planes, the coped ends command will go through and it will take the data that's there, and what will happen is we'll do a max fit of an end plane to that. The reason we're doing that is we want to go through, if you want to know what the total length of a tube is, we would definitely want it to go to the very end of that cope cutout versus, say, the ends that are inside or short. So instead of a best fit, it'll do a max fit. And that's what coped ends do.
Okay, and we have some more questions here that are coming in, just filtering through here. So we have one that's, here we go. The intersect points of a tube knows most of the time as ABC and so on. Can we align the tube using those points? So can we do an alignment using point A, B, D, or something like that?
Yes, we sure can. So that would be our typical alignment that we use, which is going through using best fit measurement objects. These are center point alignments, and we can do an alignment of everything to its corresponding measured and nominal, and that would give us a more refined answer as far as what we would get when the calculations are done.
Okay, and one last question in here, and it's been coming up a few times. Can you show where to download that IM2 macro?
Oh, sure. Let's see. So let me launch a browser. So for me, my browser basically is set up for my default page is for me to go to the technical support zone. In this case, my default home page actually logs me in. So when you log into the very first page of the technical support zone, you would actually see the dashboard. Where we're finding this as a macro would be in the macro zone. So you could simply click on the macro zone tab itself, and we'll wait for it, and scroll down into inspect process macros. And here's where you'll see the IM tube. Currently, PolyWorks 2018 IR7 was the last update for this.
Perfect. Thank you, Todd. And this is all the time we have for the questions. We still have some questions that are coming in, so you can expect an email from us to answer your questions later today. So thank you for all the questions. This webinar has been recorded, and it will be available on the Innovametrics software website. Navigate to the support section. It will also be available on the Innovametrics software channel on YouTube. And a reminder that we hope to see you at the PolyWorks Conference USA 2019 in Novi, Michigan on April 24th and 25th. The two-day event brings the PolyWorks community together for 3 PolyWorks 2019 launch presentations with embedded workshops, PolyWorks success stories by experienced users, opportunities to grow your network and strengthen your PolyWorks skills, and of course, a few more surprises of that we have for you. So for more information, visit our website at innovametric.com. Well, our next webinar, like I said, in April, we have our launch conference. So the webinars will be back in May 9th, actually, for more things. The topic has not yet been announced, so you can expect probably something with dealing with 2019. I'm not sure. Don't have the details, but you'll have to stay tuned for the details and the topics that we'll be covering in May. The details will be, of course, posted to our website. And thank you for joining us this morning, and we'll see you next time. Bye-bye, everybody.